Hello, this is Al-Sharif Mahmoud. In this video, I'll be showing how to implement jump and link to single cycle data path. Jump and link has this format. Basically, it's used to support procedures called function calls by jumping to the jump address specified, similar to the jump instruction. The only difference is that after jumping, PC plus 4 is then stored in register RA or register number 31. Okay, so again, basically you jump to this address and then you store PC plus 4 into RA. So jump and link uses the J instruction format, which is basically 6 bits in the opcode and 26 bits in the jump field. So now we need to add any necessary components to the data path so that we can implement the instruction, as well as we have to determine the control signals values. So again, so we need to assign PC plus 4 to register 31 and also change PC to the jump address specified by the jump field. So as we can see from the graph, there's no connection between PC and the wire connecting to write data. Thus, we need to establish this connection. There are several ways to do this, but the most efficient ones are the ones that involve the least amount of components, or basically no components at all. So we have the option of actually extending this mux here and connecting PC plus 4 to it. So let me choose another color. So here, let's assign a 2 for this option. Okay, now memtoreg will select between either the data coming from the memory or the data coming from the ALU or PC plus 4. Since we are using a jump or a J-type instruction, we don't really care about what instruction from 20 to 16 contain or the bits from 15 to 11 contain. So, however, like we need to actually specify that the PC is written to register 31, so we need to add this as a register to be written to. We can do this by simply also extending this mux here and then attaching basically number 31 to this mux and assigning a 2 control signal for it. That way, this mux will select either between, it can select between the RS or RT or RD or 31, which is always gonna be RD, register. So for any jump and link instruction, basically PC will simply jump, will be assigned to the jump address. So instead of selecting PC plus 4, it will select jump address, and then the instruction at this address will be fetched. And also PC will be then written back, actually the old PC plus 4 will be written back to RA. Okay, now so we can, at this point we need to specify the control signals. So starting from register destination, as we can see, this line controls the newly extended mux. So basically, for this line, for this control line, yes, we need a value of 2 to select 31, the register number 31. And for jump, we obviously need to select 1 so that the address, like the PC, is assigned to the jump address. For branch, we don't really need, we don't actually really care since jump is selecting between this or the result of this mux. So for branch is gonna be X. For memory, it's gonna be X as well. So because reading from memory will not affect anything. Memtoreg, which controls the mux that we just extended as well. So in order to select PC, we need to have it assigned to 2. ALU operation, we don't really care about the operation because we're not using the ALU anyways. And for memwrite, it should always be assigned to 0 unless we actually need to write to memory. And for ALU source, again, we don't really care because we're not using ALU. And register write, in this case, we're actually writing to register, so we have to have it as 1. And this is how you implement jump and link instruction. Thank you.